Good morning, my dear students. I hope you all are fit, fine, and healthy at your homes. And I also hope you all are studying also. So, with a fresh and new start, let's start a new chapter today. Clear? And this time we'll start a new chapter which is quite different from the previous chapters we have studied. Clear? Today we are going to deal with the part physics. Okay, physics part. Today we will start the physics part of your textbook, and with that we will study chapter 11, that is force and pressure. Students, the thing happens is when we study science, we study many different branches of science, and mostly in schools we deal with physics, bio and chemistry. Yeah, we deal with all the three parts, but among that three, okay, bio seems the easier one for students. Even I may also think, I used to think during my times, bio seems very easier, okay, and interesting too, because in bio we study about what we already know. Yeah, we know some general things, we know something which is very general, which happens to us in our daily life, what is present in our body, all those things. And then when we come to the study part, we go those things in detail. So it is a kind of interesting. Then the second mode comes when we study chemistry. Okay, chemistry is again a kind of fear for students mostly, like there will be reactions, I have to do this, that, etc. Many fears come to our mind. Then there comes the biggest fear of especially studying science, and that is physics. Okay. Students have a basically set mentality. Okay, now you are in lower classes, so you may not have, but students have a very tough mentality that among physics, bio and chemistry, the toughest one is the physics, because many of the students, they find difficult to do the numericals, derivations and many other things. Now you are not going to study all this, but in your higher classes you may. But students, this is a very basic part. Okay, you have just crossed 6th and 7th and you have just reached 8. So this is a very basic part for you where you have to study science. So my advice would be, don't think that physics is the tough one, chemistry is the tough one, then bio is a bit easy one. No. It depends on your interest. Yeah. If you take interest, the subject will be easy. If you don't take interest, subject will become tough. So in that case, today we are going to study chapter of physics. So we'll try that we can make it as interesting as the other bio chapters. Okay, so we'll try, and you will also cooperate, and you will also try to grasp whatever is given to you in a very sincere manner. So let's start with the introduction part of the chapter. Okay, in the previous classes, in 6th class, 7th class, you have started studying physics, the basic general things. In your lower primary classes also, you have studied very general things, like you have studied about light, you have studied about shadows. Yeah, from there only the physics starts. Then when you reached 6th, then when you reached 7th, you studied about motion, you studied about rest, then again you studied about speed, velocity, direction and many other things. That is actually what physics deals with, all these things. Yeah, means when we deal with the body, clear, when we deal with the body, that comes under bio. But when we deal with how the body works, the mechanical part, that comes under physics. Clear? So, for example, in our daily life, we use physics in our daily life too. Yeah. Suppose when we go and open a door, Okay, when we go and open a door or we do any work at home, we need to apply some kind of force to it. Yeah. So force is also a kind of mechanical part, and that is also coming under the physics. Yeah, it is a concept of physics. Then when we want to open a door, we just push it or pull it. Clear? Then if we want to bring a bucket of water, what we do? We have to put some force on the bucket, and then only we are able to hold it. Clear? Then for everything, suppose we are riding a bicycle. Okay, we push our bicycle, we run the pedals, and then only the cycle moves forward. Yeah, so we are applying force there. So all these are some of the daily business or daily work we do, and that actually we are doing the physical part. Okay, that is actually physics we are practicing in our daily life or the day-to-day life. And that push or pull or those things, the force that comes under the physics, and this force only we are going to study in detail in this chapter. Then when we come to definition of force, so force could be defined as a push or pull which can start or stop the motion of a body. Then it can change the direction or speed of the moving body and can change the shape of a body. Clear? See, it is a fact that if a body is at rest, you have studied in your previous classes, if a body is at rest, it is easy to make it in motion. Okay, I'm not saying that it will be taking the zero force, but no, there is some energy, some force required, but more energy, more force is required to make a moving body stop. Clear? So all these things can be done by using force. Then we use force also in our daily life. Okay, if you think, when you bend your body, when you stretch your body, when you walk, or when you hold something, when you lift something, when you kick, when you open the door, when you close the door, all these things involve force. Clear? Means every day you are using force in your daily life. Then force can be a large force can be a small one also. So there is a direction of force. Clear? Suppose we are making a running body or the moving object stop. Clear? So that object may be moving in a particular direction, either east, west, north, south, any particular direction it may be moving. So when we will stop it, we have to apply the opposite force. Suppose if the body is moving in the east side, then we are supposed to provide a force to stop it, and that force can be provided only when we apply the force from the negative part or the opposite part, that is from the west. If the body is moving east and we want to stop it, we have to apply force from west. So this is the thing what happens. So this is known as direction of force. This is known as direction of force. Now the unit of force or the standard unit of force is taken as Newton, and that is written in short form as N. Yeah. And why this is named Newton? Because the person, the scientist who invented force, okay, invented the term force, the name of that person was Sir Isaac Newton. Sir Isaac Newton. And that's why on his name, the SI unit of force is taken as Newton. Clear? In this chapter, we are going to cover the following points. First, introduction, which we have already covered. Then we will study forces are due to interaction. Then we will study the effects of force. Then we will study types of forces. Okay, then contact force, non-contact force, then pressure. Again, the main topic, pressure. Then pressure due to liquids. Then the atmospheric pressure. and then we will summarize all the points and end the chapter. So these are the points which we are going to cover. So let's start with the first point. Forces are due to interaction. Clear? Forces are due to interaction. Now what is meant by interaction? Interaction means interaction could be a kind of communication, or interaction could be a kind of gathering or meeting. So forces, according to this point, we can say that forces are never alone. Forces cannot be applied alone. Forces are due to interaction. Means when the two objects will interact with each other, then only the force can be generated or created. So that is what this point means. Forces are due to interaction. Force does not act itself. Now let's see what comes under this topic. See, when object A and object B, when these two will have interaction, then only the force F will be generated. Without interaction of A and B, force cannot be generated. So this is what means forces are due to interaction. Here force is due to the interaction of body A and body B. Now for example, we can say, suppose we want to open a door. Okay, we want to open a door. Suppose we want to open a door, we have to go to the door, we have to go near the door, then we have to push the door to open it. Okay, and if the door is locked by the handle, then we will touch the handle, then apply some force on the handle, and when our hands and the handle will interact with each other, then the door will be opened. So do some work when we apply force. Okay, force is not applied by its own. Okay, force has to be applied when two objects interact with each other, and then only the door will open. Then in the same way, we can also say that when we ride a bicycle. Okay, when we ride a bicycle, we have to push the pedals. Without pushing the pedals, without applying the force to pedals, the cycle will not move forward. So we are applying some kind of force in the pedals. So there is an interaction between our leg and the pedal. And when these two objects, our leg and our hand, the pedal of the cycle, when these two come in interaction, then only the cycle moves forward. Clear? Then for example, suppose we need to move a heavy box. Okay, we need to move a heavy box or heavy almirah or heavy table or anything. What we will do? We will try to push it. Yeah, we will try to push it. Then what happens? For example, a big almirah. Suppose a person needs to shift his house due to some reason, and he has to shift the all the utensils, all the things of his home. Then he will try to push by his own one almirah. Okay, what will happen? Will he able to move that? No, obviously it is not possible for a single man to move a big almirah. So what happens? He will try once by doing himself, but it will not be possible. Then what will happen? He will call his friends or employees or somebody else to help him. Then they will also try to move it. Then what happens? When 2-3 persons will apply the force in the same direction, then the body will start, or the object will start moving. Then the almirah will start moving. Clear? Means, for example, we can say that when one force is applied on the, more than one force is applied on the same object in the same direction, the resultant force is the sum of the forces applied. How come we can say that? See, this is a heavy box. Okay, this is a heavy box, and this is moved by 3 persons. F1, first person will give the force F1, second person F2, and third person F3. All the 3 persons are giving the force in the same direction. Okay, in the same direction. See, from this side only all are giving. See the arrow? Then what will happen? the total force applied on this object will be the sum of these three forces. F is equal to means total F. The total force applied on the object is equal to F1 plus F2 plus F3. This is what means that when more than one force is applied on the same object in the same direction, the resultant force is the sum of the forces applied. Clear? So, I hope you are clear with it. Now, sometimes what happens, we may not provide the direction, we may not provide the same direction of force. For example, let's see. See, this is again a heavy object. Clear? Here, the difference is that two persons are applying the force from the opposite parts. See, F1 is doing from this side and F2 from this side. Then what will happen? If the direction of the forces are different and they are not same, in that case, the body will move or the object will move towards the larger force. Suppose this person is a thin person applying less energy. Clear? This person is a fat person or an elder who is applying more energy. So obviously what will happen? The object will move to the opposite side of this person. Clear? So the resultant force will be taken as the difference of these two forces. If F2 is greater, F2 minus F1. If F1 is greater than F1 minus F2. This is what we say when the different forces are applied with different directions. Then we take the difference of the forces being applied. And when the forces, the direction of forces is same, in that case we take the sum of the forces applied. Clear? Then finally we can say that if the two forces acting on an object in opposite directions are equal, the net force on the object is 0. Now what will happen? See, when one force was more than the other force, then we were saying we are taking differences, F2 minus F1. But if both persons are having same energy, both are applying the same force, same amount of force, suppose F1 50 N means 50 Newton, then F2 50 Newton. In that case what will happen? F2 will be 50, F1 will be 50. F2 minus F1, 0. So the net force applied on the object will be 0 that time. Because F1 is also pushing from one side and F2 is also pushing from with the same energy from the other side. So the object will remain in its own position. Clear? And the applied force will be 0. One example for this which we can take in our daily life is the tug of war competition. In the tug of war, mostly there are two teams. Okay, both the teams are applying force from both the sides, opposite sides. And you may have noticed that the number of persons in the left side and number of persons in the left side and the right side are almost same. Means if 10 are there in the left side, there should be 10 in the right side also. Then both the teams will try to move the rope, try to push the rope towards their side. Clear? But if the number of forces or the amount of forces applied is same, clear? The rope will not move towards one side. It will keep on imbalancing. Clear? So this is an example of this kind of force. So from these examples, from these things, we come to know that and we are clear that a force could be either larger or it could be a smaller force. Clear? And the amount of force, clear? The force will depend on its magnitude also and its direction also. Now you may wonder, what is magnitude? The magnitude means the movement of the object from its starting position to the final position. Suppose, see, in this example, you can see one object A1. Clear? It has moved 5 meter distance and reached here and it became A2. Why? Because the force was applied to A1 and then only it moved 5 meters further. direction. Here the force was applied on the direction of A2. Clear? And when the force was applied in the direction of A2, this body, this object moved forward. Clear? So this 5 meter will tell the magnitude. If for example this will not move, suppose this instead of object this is a wall and this does not move, then what will happen? Magnitude will be 0. Clear? Means magnitude should be something which allows the object to change its position from its initial point. Okay? Then only we can say that there is some magnitude. And in the force, magnitude and direction both are important. Clear? So, effects. Effects of force. Effect means something which happens after application. Okay? After application means when we apply force, there are some effects which occur. Clear? Means what a force can do, that we are going to study under this. Clear? Unfortunately, we cannot see force. Okay? Force is just a kind of feeling, we can say. It's just a kind of feeling. We feel that we apply force, but we cannot see a force. Yeah, like we cannot see a air, we can feel it. In the same way, we cannot see the force. We can just apply it and imagine that we have applied the force. We can feel it. So, how we can feel that we have applied a force? For example, a person is pushing a wall. Okay, a person is pushing a wall, and all of you know that a wall cannot be moved. Yeah, a wall cannot be moved because it is a stable thing. We cannot move that. And a person is completely sweatized. Okay, sweat coming, and he has tired himself so much, but even then the wall is not moving. So how can he say that he has done a work, he has applied force? So when we see something moving with the application of force, then we can say that yes, force is applied. So these are the ways by which we can know that what force can do and what are the effects of force. Let's see one by one what are the effects of forces. Number 1. A force can cause motion in a stationary object. Yeah, means it can make a body which is at rest to move from the position of rest and come in motion. Clear? For example, if we just push a toy car, okay, we just push a toy car, or say we push a ball, football or any kind of toy, we push and it changes its place. Okay, it was in rest, but with a sudden push given by us makes it move from its place to another place. Clear? So this shows that we have applied force on the object and the object started to move. Clear? So this is what force can do. A force can cause motion in a stationary object. But it's necessary that we should apply a sufficient force to move an object. Clear? It's easy to move a toy car with a very less force. Clear? In the same way, for moving the heavier objects, we need to apply more force. Clear? So this is the first point, the first effect of force. Force can cause the motion in the stationary object. Second, just opposite. First, it could make a rested body to move, and second, it can stop a moving object. Yeah. For example, a bicycle is moving and we just apply the brake, Okay, apply force on the brake and it stops. So by applying force, we can make a moving body to stop and come at rest. For example, many of you may be watching cricket, especially boys. So you may have seen the cricket fielder. Yeah, he stops a moving ball when the batsman, okay, he is doing the batting and he runs the ball. Then what happens? The fielder who is standing to the other side, he tries to catch the ball. And as soon as he tries to catch the ball and catches the ball stops moving. Otherwise, if the fielder is not able to catch the ball goes outside the boundary. Yeah. So, that is only called sixer. Yeah, sixer. I don't know much about cricket, but yeah, you may have seen fielder. It is a very common thing. The fielder catches the ball and he tries to stop it. Okay, that is also an example that a force applied can stop a moving object. Clear? Now third, force can change the speed of a moving object either in a positive way or in the negative way. Means it can decrease the speed also and it can increase the speed also. For decreasing the speed, for example, if a force is applied in the direction of motion, okay, suppose a ball is just in a very low speed, a ball is moving and suddenly the sportsman kicks the ball in the same direction. Okay, that will increase the speed of the ball in that direction. But for example, if a rolling object, suppose we are moving from a lift, or you can say in the stations you may find especially in the hospitals you may find the rolling slope. Yeah, it is called slope. You can find the slopes, means stairs are not there. It is made in the position like the stairs, but stairs are not there. It is a flat surface, slope. So there, if you are taking a trolley, okay, you are having a trolley with you and it is having the wheels. So as soon as you will take it into the slope, what will happen? Your trolley, the wheels will make your trolley to move in the direction of motion towards downside. But if you hold your trolley tightly and you apply force in the opposite direction, okay, other than going downwards, pushing upwards, what will happen? The speed of the rolling object on the slope will automatically decrease. Yeah. So force can do the both things. It can increase the speed and it can decrease the speed also. Unless and until the condition is if the force is increasing the speed, then the force is to be applied in the same direction of motion. But if it is decreasing, then it should be avoided in the opposite direction. Clear? Number 4. A force can change the direction of the moving object. Now, how come it can change the direction? Firstly, according to the direction, it was changing the speed. Now, we are seeing that it changes the direction of the moving object also. For example, we'll just roll a ball. Okay, we'll take a ball and we will roll it on the floor. Clear? Now what will happen? We will just place a ruler or an obstacle in front of it. Clear? For example, you are having a toy car, especially that small toy car which children play. That toy car, you just made a push to the car and started moving. Clear? Suddenly, you bring an obstacle, you bring a table, you bring a chair, or you bring a brick or anything. You bring anything on the way of that toy car. What will happen? It will just go bounce it and it will change its direction. Yeah, it will change its direction. So this will show that the ruler or the object, whatever you have kept, it is a brick or it is a table or it is a chair, that object has applied a force on the moving object, means our toy car. And in that case, what happens? The direction of the moving object changes. Clear? Then in the same way, in the game of tennis, you may have seen the tennis game. Okay, either you may have played or you may have seen on the television. Yeah. So what happens there? There is a net. Yeah, there is a net. Then what happens? When they are taking the ball and hitting the ball, and it touches the net, then what happens? It changes its direction. It comes to the opposite side. Yeah. So, and sometimes in the cricket also, you may have seen when the batsman is batting and he hits the ball with the bat. Sometimes it happens that due to extra force applied by the batsman, the ball moves towards the backside of the batsman himself instead of going towards the forward side. So these are the examples which shows us that force can change the direction of a moving object. Clear? Then, now we are saying that force can change the shape and size of the object. Now how come it can change the shape and size of the object? For example, see, you all like chapatis? Yeah, we make chapatis at home. Not you, your mothers are making, but even then, we eat chapatis at home. How it is made? First, the wheat is crushed. Yeah, the wheat is crushed into flour. Then when it becomes flour, it is brought to the home. Then water is mixed with it and a dough is created. And with that dough, the chapatis are made. So that dough is not a simple thing. Simply adding water will not create a dough. Yeah. We have to apply force on that wheat flour mixed with water. Then only it forms a dough. So that is one of the example that first it was a solid particle. Yeah, it was like a powder. Suddenly we added water, we applied force, it changed into semi-solid. Yeah, semi-solid means water mixed with it. Now it is not the powder one. It has become something else. It has created into dough. So this is one of the example where you can see the shape. Yeah, the shape of the wheat flour changed into dough. Then another example, sponge. You may be playing with the sponge, or you may have seen what happens with the sponge. As soon as you press it, the size becomes smaller and it is crushed. Yeah. Then rubber band is also an example. When we stretch a rubber band, its size changes. Then again when we relax it, again the size changes. So, and clay, you are making projects with the help of clay. So that clay is also an example that force can change the shape and size. We apply force and make different designs using the clay, and the structure, the texture of the clay changes. So this is how force can change the size and shape of the object by applying force. Now, for example, if you squeeze an iron ball instead of a plastic ball, you are squeezing an iron ball. Will it change its shape or size? No, it will not change. So, a force will never bring a change in size or shape of the object unless and until the object or the capacity of the object favors. Clear? The objects with low tightness or which are not so hard, softer substances, for this condition is appropriate. but for the things like iron, metal, for these substances, force cannot change their shape and size. Clear? So these are the 5 effects of force. These are the things that force can do. You may think of many more if you remember, and from your daily life you can go for many other examples, many other effects of force. Clear? You should not bound yourself to only the textbook matter. Clear? Now you are the growing up students. Then you have to go to higher classes also. So you should prepare yourself for more and more. Simply surfing the internet for video games and this and that and wasting your time, you should invest your time in finding something new. Clear? I know a textbook is provided to you from the school side, from the syllabus and everything, but it's not compulsory that you should just bound yourself to a textbook. You should not become a frog of a well. Yeah. You should come out of that well. And that well is your textbook. You should come out that. You should study everything in the textbook, but you should try more. Yeah. You should try more. Science is a subject where the information you get is never and ever complete. Yeah. Science is a subject where you can gain more and more, where you can find out more and more. That's why science is about changes. Clear? If the things which were already found out by some scientist, some biologist, etc., if the other persons would have thought that okay, everything is done and we will not find anything else, then the new discoveries, new inventions will never be possible. So you should try to gain more and more, especially in the subject of science. Okay, you should not be a frog of a well. You should come out of that well, and you should gather more and more information, either through internet, or you can ask your teacher. You can ask me or your teachers, and you can gather more and more information about the topic. Clear? So that will increase your thinking power, that will increase your knowledge skills and everything. Clear? Because in this era, you are not only preparing yourself for the annual examination, first terminal, second terminal, etc., but you are preparing yourself for the competitive exams. This is the era of competitiveness. So you have to prepare yourself for that. So don't just relate with this only 5 effects of force. You may get, you may not get. I am not saying that you will, surely everyone will get. I am not saying that surely everyone will not get. You may get and you may not get. But if you don't get once, it's not that you will stop searching. Just go on. Think of it. Make your own. Clear? Okay.
Effects of force. Force produces effects on shape, motion, direction and speed. Effect on shape. Take a balloon filled with air and press it. Its shape changes. A metal rod bends on being given a few hammer blows. From this, we can understand that force can make a change in shape. Effect on motion. A force can make a body move and can stop a moving body. For example, when we kick a football, it moves through the ground. But when we catch it, it stops its motion. Effect on direction. A hockey player strikes the running ball to change its direction. From this, we can understand that a force can change the direction of a moving body. Effect on speed. A force can also change the speed of a moving body. For example, when you're pedaling a bicycle, If someone pushes you from behind or pulls you back, speed of the cycle changes. Let us now define force. Force is the push or pull which can make a body move, stop a moving body, change the direction of motion of a body, and change the speed of a moving body.
Now, our next topic is types of forces. So students, there are two kinds of forces mainly. Clear? One is contact forces and the other is non-contact forces. The name itself is telling that contact forces means the forces which will act only when there is a physical contact. Either it is direct contact or it is indirect contact between the objects. Then only the force will act, and that is called contact forces. But when we come to non-contact forces, in these kind of forces, the contact is not necessary. The interaction is not necessary. They will act, this force will act even if there is no physical contact between the objects. Clear? So there are many subtypes of these forces. Let's see what are they. Under contact forces, we have muscular forces, mechanical forces, then frictional forces. Then under non-contact forces, we have magnetic force, then electrostatic force and gravitational force. You may have come across these terms many a times in your previous classes. Yeah. So these forces, the main category of these forces are contact and the non-contact ones. Now let's see one by one all the forces, that what does they mean and what are the differences between them. When we see muscular force, clear, and we have seen that muscular force is a type of contact force, clear, and the name is telling that it is applied by the action of muscles. Clear? When the muscles of the body work and apply force, then we call it as muscular force. For example, we are lifting something which is heavy. Suppose we are lifting a bucket of water, full bucket of water. That time also our muscles are working. So that is example of muscular force. Then pulling of parts by animals, that is also an example of muscular force. Yeah. So wherever the force is by the application of the muscles, where the muscles are utilized, that are called the muscular forces. One more example is movement of our body parts. Okay, our body parts, suppose our hand, our legs, okay, we are able to walk, we are able to jump and everything. All these are because of muscles. Clear? So that is also a kind of muscular force. When our muscles apply force on our body parts, then they tend to move. Then one more example, our blood. Clear? We all know that blood is present in all the body parts. Everywhere the blood is present. So this body is pushed into the arteries by the muscular force exerted by our heart. Our heart exerts the force on the blood, and then only it is transferred to the arteries, vein. You have studied about circulatory system or not? Circulatory system, what happens? In the circulatory system consists of heart, it consists of arteries, it consists of veins. Clear? From there the blood starts moving and then it gets transferred into all the parts of the body. So that is a different topic from here. So we will not go in detail. So that is also the muscular movement. Just to tell you that movement of blood, the transfer of blood is also an example of muscular force. Then the mechanical. Okay, mechanical force is another example of contact forces, and here instead of muscles, the action of machine is there. Clear? The forces applied by the machines are called the mechanical forces. Yeah, a machine does not work by its own. Can it? No, it cannot. It needs energy from other sources. Yeah, all the machines need energy either in the form of electricity or in the form of solar energy or in any other form, but they need some kind of energy sources. For example, the engine of a car. Yeah, engine of a car starts when we put petrol in the engine, diesel in the engine, then only engine works. And engine gets started and the car moves. So that is an example of mechanical force. Clear? Then sailboats, okay, which move in water. The sailboats also take the force exerted by the wind to move across the water, and then only they are able to sail. So this is the example of mechanical force. Clear? Muscular force means action of muscles. Mechanical force, action of machines. Then comes the very important one, that is frictional force. Yeah? For frictional force, force of friction or frictional force. See, when you touch a surface, suppose you are able to stand, okay, you are able to stand on the earth because of friction. Friction is a kind of force, equal and opposite force, that is applied by the another object. Clear? Suppose we are standing in a particular road or in our homes. We are able to stand because of friction. When we start walking, when we start moving, clear, our legs and the earth both come in contact. Clear? Both come in contact, and that generates the force of friction. Our leg applies force on the ground, and the ground applies equal and opposite force on the leg, and that's why we are able to move. If there was no friction, we would not be able to move. We would have just been flying. Clear? We would not be able to keep our legs stable at one place. Even when the vehicles, car, bikes, scooters, buses, everything, they are moving on the road, then the tire is the one object and the road is the second object which are coming in contact. And due to this contact, force of friction generates and the cars are able to move on the road. So that is called force of friction. A frictional force always changes the motion of the object. Okay, the frictional force always changes the motion of an object. Yeah, means either its speed or its direction, everything that is controlled by the frictional force. Now we can say that a friction can stop a moving body. Yeah, a friction can stop a moving body, or it can also make a moving body stop. Yeah, so this is what about frictional force. So I hope you are clear with muscular, mechanical and frictional force, which are the three types of contact forces. Now come to the non-contact forces. First is magnetic force. See, the force that is caused by the magnet are called magnetic forces. You all would have played with the magnets. Played or not? Yes. And we know that magnets are when brought near the objects, especially made of iron, they get attracted and get attached to them. Clear? Here in this diagram you can see this magnet. Two poles are there. This filled one A and the non-filled one is B. See, both magnets are kept in the same manner. See, AB, BA. AB, BA means see, B1 and B1 are coming in contact. But here the repulsion will occur. Repulsion is the opposite of attraction. Means when the two poles are same. Yeah, here also B, here also B. They will not attract each other and will not move to each other. Instead, they will move far away from each other. This is called repulsive force. Then in this diagram you can see AB, then again AB. B and A. Two different poles are coming in contact. In this way they will form the attraction, and this force is called attractive force, and here the magnet will come in concentration. So the forces which are applied by the magnet are called magnetic forces. Clear? The forces which are acted upon by the magnets are called magnetic forces. Clear? So you are clear with magnetic forces? Now what happens is, here physical contact is not needed. See, when the magnets came closer, just they were little far from each other, but simply they attracted and came closer. So here mainly this force does not apply, does not require any kind of contact or physical contact. That's why it is coming under the category of non-contact forces. Then the electrostatic force. Clear? It is the force exerted by a charged body onto another charged or the uncharged body. In your childhood, you may have played a game. You can try it now also. Just while watching the video, you can try. Just take a ruler, take a scale, clear, and just rub it on your hairs. Just rub it on your hairs and take a few small pieces of paper on the table or on the floor anywhere, and after just rubbing that scale onto your hair for a few seconds, you just bring that ruler near the sheets of paper, and you will find that being at a distance itself, the papers will start sticking to the ruler. Clear? Ruler. Why? There the electrostatic force started to work. When you rubbed, clear? When you rubbed the scale or the ruler on your hair, what happened? A force was generated there. Clear? A force was generated there. The body, the scale, the unmoving object, non-moving object scale now came into charge because of the rubbing. And when you brought that charged body towards the uncharged pieces of paper, they also got charged. And this is called electrostatic force. Clear? Then the third, gravitational force. Clear? This is the force exerted by the earth. See, whenever we throw something from the top, suppose you are living in a bungalow of 3 floors, you are throwing something from the 3rd floor, from the terrace. What will happen? Anything. It can be a ball, it can be a apple, it can be anything it can be. When you throw it, what happens? It is just falling into the earth. Is it falling into the earth or is it just flying? Obviously it falls on the earth. How it falls on the earth? Because on this universe, not only the earth, but in this universe, one object is dependent on the other. Clear? One object exerts the force on the another object. For example, our moon. Clear? Our moon is in its position on the earth. Why? Why it does not fall? Why it does not change its position? Why? Because the force is given to the moon by the earth. And that's why due to that force of gravity only the moon is stable. Clear? Otherwise what happened? What will happen? The moon will be just flying here and there. Imagine the situation. What will happen then? So, the force exerted by the earth is called gravitational force. And you may have noticed one more thing, that suppose for example, you are standing on the terrace and you are throwing a pencil. And you are throwing simply a small pencil and you are throwing a book. Clear? A book, a fat book. Which will go first? Pen will go first or the book will go first? Which will go first? Think of it. In that case, the object which is having the more weight will go first. Clear? Because greater the mass of the object, greater is the force applied by it. When something flows from the top, okay, falls from the top, the object which is falling is exerting a force on the earth, and earth is exerting an equal and opposite force on the object, and that's why the objects just fall into the ground. Yeah. So this is gravitational force. And one more thing inside this is Sir Isaac Newton was the first person to find the gravitational force. Clear? He was the first man to identify that there is a kind of force known as gravitational force. How? See, he was observing an apple tree. Okay, for so many days he kept on observing. Then every day he found out one of the apple, two of the apples, they are just falling on the ground. Simply they are falling on the ground. And his question was, how can this happen? Why always this happens that apple falls on the ground only and nowhere else? Why? So with so much of thinking, with so much of discussions, he came to the conclusion that there is a force of gravity acting on the tree to the earth and from the earth to the tree, and that's why the apple falls on the ground. So this is how he found out the gravitational force. So these three are the types of non-contact forces. I hope you are clear with whatever we studied today. This is regarding force. In the next class we will start the next topic, pressure. Clear?
Contact forces are the forces that act between the objects when the objects are in contact with each other. We have already discussed what a muscular force is. It is the force that is generated due to the actions of muscles in our body when a body is applying force on any object. Muscular force is a contact force. Another contact force that we can talk of is the force of friction. What is force of friction? Try rolling the ball on a horizontal plane surface. What do you notice? You noticed that this ball gradually slows down after some time and eventually comes to a halt. Why does this happen? Why doesn't the ball continue to move in the same direction forever? The reason for its slowing down and ultimately stopping is the force that this surface applies on the ball when it's moving. Yes, the surface applies the force on the ball, and the direction of this force is opposite to that of the motion. So when the ball was traveling towards the right, the surface was applying a force on it towards the left. The force applied on the ball by the surface is called the force of friction or simply friction. Friction plays quite an important role in our daily life. We can walk and run because of friction. How does it help us walk? When we walk forward, we push the ground with our foot in the backward direction. In return, the ground exerts a force in the forward direction which moves us forward. The force that the ground exerts is nothing but the force of friction. The examples that we've seen till now are the ones in which the frictional force exists between solid objects. Now consider a boat moving in a quiet lake. In order for this boat to move, the person in the boat must continuously row it. Now, if he stops rowing it, will the boat move forward? No. Just like the rolling ball stopped at the solid surface, the boat will also stop eventually in water. It stops because of the force of friction between the water and the surface of the boat, which is in contact with the water. So from all the examples that we've seen in this video, what can you conclude about the force of friction? Is it a contact force? We see that in the first example, the ball was in contact with the surface. In the second example, the foot was in contact with the ground. And finally, the boat was in contact with the surface of water. So we can safely say that force of friction is indeed a contact force. Take a bar magnet and place it on the table. What is a bar magnet? Well, we all know what magnets are. Bar magnet is an artificial magnet which has this shape. Place an iron nail on the same table at some distance away from the bar magnet. Now move this bar magnet towards the nail like this. Keep moving the magnet slowly, closer and closer to the nail, but make sure not to touch the nail. What did you notice? When the bar magnet was sufficiently close to the nail takes a leap towards the magnet and sticks to it. What does this tell us? This shows that the magnet attracts the nail and the contact is not necessary for this attraction. The magnet pulled the nail towards it even though it was not in contact with the nail. The force that this magnet exerts on the nail is called magnetic force. So contact is not required for the magnetic forces to come into play. We call this force a non-contact force. Now if you bring this magnet close to your iron cupboard, you will get the same results. As you move this magnet closer and closer to the iron cupboard, the magnet will attract the cupboard towards itself and vice versa. However, in this case, it is the magnet which will shoot out of your hand and stick to the cupboard. Are there any other non-contact forces besides the magnetic force? When you release an object, say a plastic ball, from some height above the ground, it just falls on the ground. Why does it fall towards the ground? This is because of the force that the earth exerts on it in the downward direction. The earth always pulls the objects towards it. This force that the earth exerts on an object is called the gravitational force. This force is attractive in nature. That is, it attracts two objects towards each other. When you open a tap, water begins to flow downwards. This is because of the gravitational pull of the earth on water. Now I want you to tell me, is gravitational force a non-contact force? Yes, it is. We can clearly see from our examples, the contact is not required between the earth and the other object to attract each other. We say that the gravitational force is a non-contact force.
There are many types of forces. Let us study about the different types of forces by performing some activities. Activity 1. Take a few iron nails or pins and keep them on a piece of paper. Bring a magnet near them. What do you observe? The nails or pins move towards the magnet and get stuck to it. The force by which the nails are attracted towards the magnet is called magnetic force. Activity 2. Take a plastic comb or a plastic scale and rub it on your hair for a minute. Bring the comb or scale near the tiny pieces of paper. What do you observe? The pieces of paper are attracted towards the comb or the scale. The force developed by rubbing the comb or scale is called electrostatic force. Activity 3. Throw a ball upwards. What do you observe? After reaching to some height, it comes down to the ground. Why? Because our earth exerted some force on it and pulls it down. This pull of the earth is called gravitational force. Activity 4. Roll a ball on the floor. After some time, it stops. Though no force is applied. What makes the ball stop? There is a force of friction between the surface of ball and the surface of floor. It is this force of friction that makes the ball stop after some time. When any object moves over a surface, the force which opposes the motion of an object is called frictional force. Look at the boy running and the girl lifting her bag. They are using muscular force.
Dash is the unit of force. Newton is the unit of force. Then second question. The force responsible for change of motion of objects is called dash force. Which force? Frictional force. Okay, frictional force. Then third question. If a force is applied in opposite direction, the speed of the object will dash. What will happen? It will increase or it will decrease? It will obviously decrease. Clear? Now, home assignments. First, state the effects of force other than what is given in the textbook. Clear? 5 is given in your textbook. You have to find out more. Then second, define electrostatic force. Then third, give one example of each type of force. Means 6 type of forces are there. You have to give one example for each. Yeah, so this is your homework. I hope you all will do the homework. At least you will try to do. And with that, we end today's class. And in the next class, we will study about pressure. Till this, if you have any doubt, you are free to ask me anytime. And try to read the chapter clear and go through the video well. And try to clear the terms. Thank you. Have a nice day.